Hi Emma, probably the easiest way to do this is just to make you a quick video and then send it to you. So I'm not quite sure exactly what you have done, but let's just look at an example question and see what we can do with it. So I might, for example, want to know about sine of 150 degrees. Now, it doesn't matter that that's a multiple of 30 or multiple of 60. What we're interested in is thinking, how can we find it using what we know about graphs. I'll show you how to do it in the cast diagram as well, but the graph kind of makes this hopefully a wee bit more obvious. So 150, well, there's 180 degrees in our graph. So 150 is along here. Now, this is reversing one of the processes we've already done, because we can spot that that is exactly the same as whatever the height of the graph was over here. Well, what is this matching one? Well, there's our 180, and we're coming back from 180 by 30 degrees to get to 150. That's the same as coming forward by 30 degrees. So the key thing about this is not maybe the multiple thing, although you could possibly do it that way. But our key thing is to spot that it's 180 take away 30 degrees. That's going to be the key link that allows us to solve this. Now, if we look at our graph, we can see that they're both positive. So the value of sine 30 is going to be absolutely identical to the value of sine 150. So if we've got sine of 30, that's a half, and that means our height here is a half. So sine of 150 is also a half. So that's kind of the game that we've played. We've put it in, we've worked out how to kind of work our way backwards using the graph. If you wanted to use casts, we can do exactly the same thing. So a wee bit trickier, in my opinion, to think our way through. But 150 is around here. That has a matching angle that comes out here. So coming back from 180, or in this section of our cast diagram, 180 take away a relative acute angle is the 150 degrees. That means our relative acute angle is 30 degrees. Now, looking at our diagram tells us that we're working with a sine, and sine is positive here and it's positive here. So whatever our value of sine 30 is going to be exactly the same around here, because they're both going to be positive values. So that's a kind of overview of what we're trying to do. Now let's look at a slightly trickier example, which includes some negatives, and then hopefully it'll make more sense of what I was doing here. So cos of, and let's go for 240 degrees. Now we somehow need to relate that back to one of the angle facts that we know that's less than 180. Well, I can spot that that is the same as cos of 180 plus 60. So you're always trying to relate it to adding or taking away 45, 30, or 60, which is where our link to the exact values table comes in. If we draw our graph, sorry, I went a bit wonky at the end. Cos of 60 is up here. There's 180. But now we can see that cos of 240, well, this is 270, so 240 is somewhere in here. Cos of 240 is definitely not quite the same thing going on as up here, because this one is down negative and this one is positive. But we said that going from 180 to 240 was moving along 60 degrees. That part of the graph's moving along 60 degrees. So the position is kind of the same, but here it's a negative and here it's a positive. So if we know that cos 60 equals positive a half, which is up here, then we can see that cos of 240 is coming up from -1 by the same amount we came down from 1 here. So cos of 240 is the same value of a half, but it is negative instead of positive. Now you could have done that on a cast diagram in the following way. Here we know our relative acute angle that we're interested in is the 60-degree bit. But our 240-degree angle lands somewhere in here because this is 60 degrees beyond 180. That's what we wrote down in this section. But what's happening down here? Well, cos is negative on that part of our cast diagram. So that's kind of where the cast comes in, because we can see where the angle lies. It tells us that cos is negative in this section. I will do one more like that. I'll do one with a tan just so you've got another example to work with. So let's go tan of 315 degrees. I might be giving you one of the answers in the assignment for free. I can't actually quite remember what's in there. Now I'm looking at that and thinking, ooh, 315, probably related to 45. And a little bit of thinking tells me 360 take away 45 degrees gives me tan of 315 degrees. Graph approach. Quick tan graph. Well, if I do tan of 45, that's 180. Tan of 45 is there, but tan of 315 is down here. So if I am coming back by the same distance I went along there, then I'm going to be the same amount below the y-axis there as I was above the y-axis there. So if I can remember what tan 45 is from my table, that's 1. So along here, from my graph, tan of 315 must have value 1, but it's below the axis, so it'll be a -1 that we get. Similarly, you could do it with cast. Sorry, I didn't plan this in advance, so it's a little bit of a mess. Doing that with cast, there's our 45 degrees, but we're now talking about an angle down here. Well, cos is positive, but sine and tan are negative in this section. So if I've got an angle down here, tan is going to give me a negative value. So it's the same as my cos 45 value, but it's going to be negative because we're in this section of our cast diagram. Hopefully that makes a little bit more sense out of it, but if you're still unsure, please do ask again. That's absolutely fine.